I'm starting the recording. Hopefully it continues. It's a free version anyways. Okay. All right. So everyone knows that, we talk about artificial intelligence, machine learning, Gen AI, LLMs, deep learning. But where do they exactly fit, right? So that is a question that a lot of people have. And I've been teaching data science from almost 3.5 years now. Every session that I start with people, if I ask people, what do you know about AI and machine learning or deep learning? So everyone gives a different answer. So this structure gives a clear picture of how they are structured, right? So artificial intelligence is the larger umbrella. Okay. It is the broader field, which again aims to do what we all think as a human only can do. The intelligence that we talk about is the algorithm behind it, and that algorithm would be able to perform the task that in general terms only a human would be able to, right? But there are multiple ways to do it. Machine learning is a branch under artificial intelligence, okay, that specifically teaches computers from the data. All right, the data that your enterprises would have, or unseen data as well, that is getting generated when an algorithm is being put on a system, right? So it's learning from those. Deep learning, everyone would have heard about the terms called neural networks, you know or neurons, deep networks, etc., etc. So that all comes under deep learning, but it's also a branch of machine learning. It's part of machine learning itself, right? So at this point, people call divide it into two parts. They call traditional machine learning. So most of the model that comes from scikit-learn, that's a library in Python. I won't assume that everyone knows about those things, so I'll just give more details about things. So the family that talks about linear regression, logistic regression, all those algorithms which are not very infrastructure heavy, right? So when we talk about those, we say those are now traditional machine learning models, right? But when we talk about transformers, we talk about neural networks. I mean, there are multiple kinds of neural network as well, but let's not go there, right? But when we talk about a very dense layer of algorithm, we are talking about deep learning. Okay. Within deep learning, there's a branch which is now the most popular one. I assume that every one of us in some way or form is using Gen AI, right? At least ChatGPT, Gemini, Grok, Perplexity, whatever we are using, right? That's all part of generative AI. Now, does data science fit in? Data science is a branch that takes benefit from all of that, right? And utilizes its data to finally, you know, gain understanding for your organization, for your management, that what this data's patterns tell about you. You might be forecasting, right? Forecasting for, in next 3 months, in next 6 months, what is going to be your sales, right? If a specific marketing campaign is able to target and give you the result that you were expecting, maybe you were expecting 2x or 3x revenue increase after putting a lot of money in a specific marketing campaign, right? If you have clear data, you will be able to get this as an output, or as an you'll be able to analyze it and put it in a form that your management can actually make out that is something helping you or not from the marketing perspective. And for other domains as well, if I talk about my organization, we deal a lot of with a lot of legal data. So if I use data science to be able to see from that data, if if the output that is generated by the manual work that a lot of legal experts are doing is up to the par or not, they are actually able to do what they were supposed to do or not. So I'm easily able to evaluate them with the different models that we have put in place. Okay. So on a larger terms, AI, machine learning, deep learning, Gen AI, and data science, this is the larger picture or larger umbrella. Okay. I hope from this time onwards, if you know, if you hear the term machine learning, artificial intelligence, you don't get confused that these are separate things, or does AI comes under ML or ML comes under AI, right? So this is just a structure. This is just starting point for everyone to understand. Any questions on this? I'm expecting this session to be very open, right? All of you are very senior, industry people. So I'm hoping that you would be very vocal. Please ask any questions on this specific topic on this specific slide if you have. Okay. If you won't ask questions, I'll assume that I'm very good at it and you all understood. Okay. All right. Let's move to the next one. Now, before going little deeper into the rest of the terminologies, it's better for us to understand what is the different type of data. Okay. So all the models that we see are utilizing some type of data, and that is what bifurcates them, right? The different categorization of different models is based on the kind of data they are made for. Okay. So on a higher or a broader level, we have numerical and categorical data, right? Rest of the data I'll also come to, but most of the people working in enterprise applications or enterprise organizations, or even for those organizations which are providing services, most of the data that you'll deal with would either be numerical or categorical, right? Then time series data comes specifically for those people who are into either stock prices, or you want to forecast about a specific term that requires very less number of variables, mostly just one, right? So let's start with numerical. What do we call a numerical data? We call numerical data that can be put in numbers, right? There are two things in it. One is continuous, one is discrete. So I've put in a very simple example for us to understand what is continuous and what is discrete. If I measure your height, I can go from 1 centimeter, 1.5 centimeter, 2 centimeter, 2.5 centimeter, 2.5 centimeter, 2.75, and so on, right? So there's a continuous nature. If you plot it on number line, you would be able to see that you can go from A to B, and at any point in between, you can pinpoint. So that becomes your continuous data, right? Now, a second form is discrete data. Discrete data is that data which would which cannot be specified in decimal points, to be very simple. Like if I ask someone, how many cars do you have? You cannot have 1.5 cars. You cannot have 2.1 cars. You will have one car, two car, three cars, right? So these are very discrete numbers. Similarly, if I ask you how many children you have, whoever has it, they will answer, I have 2.5, answer 2.75 children, 2.5. It will be a discrete number, 1, 2, 3. So that is your discrete numerical data. Okay. Now, for continuous data, you'll build different kind of models. For discrete data, you'll build different kind of models. But I don't assume you to be directly building, but because you're not directly dealing with, or working as a data scientist or AI person, but you would at least grasp that what kind of data it is, and based on that there would be a different kind of models, so that you'd be clear in that term, right? That's why I've started with this. Now, second thing is categorical data. So categorical data, as its name suggests, it talks about categories, right? So you talk about you know fruits and vegetables, right? So fruit is a category, vegetable is a category, right? So those all categories within which you could have subunits, that becomes a categorical data. It also have two types. Again, it can have multiple depending on if you go to different industry people, but in general, on a high level, it can be easily divided into two things: nominal data and ordinal data. So nominal data is anything that has some categories but there's no order to it, right? So if I ask you, you know look at different people in this group, all right, and just by the color of the logo which is showing on the screen, from that you divide them into different groups, right? So there's no order to it. But if I ask you within the same group, divide people based on their alphabet, in an alphabetical order, from the name, from the starting of the name. So then there's an order, right? People, it will start from A, then B, and C, and D, right? So that is nominal and ordinal data. So this is the larger category, right? But that doesn't mean that data is not divided in other parts. So let's go to that. Next is time series. Now time series is a different kind of data, right? For numerical and for categorical data, you can have multiple kind of variables, right, that is affecting, and you can take each at different point. For an example, if I say that, you know for let's take an example from cricket, right? If you're going to take data about a cricketer in different years, right, you would be talking not just about one factor. You would be talking about their batting averages, you would be talking about their strike rates, you would be talking about number of hundreds they have made, right? So these becomes all different variables about that data. All right. Similarly for categories as well. Now, how time series data differs is, when we are forecasting with the time series data, we are only talking about one variable, right? So for an example, if you go on Google and search about, say Meta's share price or Reliance Industries Limited share price, you will get only one variable that is charted, right? That variable, what would that variable be? The stock price, right? Other than stock price, which has been taken on regular intervals. So that is again one more thing about time series data. For numerical and categorical data, you can take at any point, right? But for time series, it always has to be at equal interval and should only be talking about one variable. Okay. Now rest is text, audio, and image. This is all what we call unstructured data, right? All the GenAI applications that you have interacted with, all of them, they all work with unstructured data. All right. It could be text, it could be audio, it could be images. So for this one, I think this is enough, but let me know any questions on this, anything that is related to this that you feel you might have questions on.
Hey, I have a question. So,
Yes.
do we have models for all of these data? Like, for example, nominal data, which is like very less, but still, do we have models that works on it?
For each category there are different kind of models, right? For continuous you'll have different kind of models, for discrete you'll have different kind of models. That doesn't mean that one model cannot consume multiple types of data, right? But the output that you're looking for would vary or would actually tell you what kind of model you should be using. So it's more about the output that you'll be trying to get. Based on that, the input you'll have to decide. So if you have both continuous as well as discrete data in your inputs, and you want an output that is, say, specifically a discrete number, right, or a continuous number, so these things would differ in that way. So for an example, if I tell you uh, house price prediction, right? One of the most common examples that everyone takes. All right. So within house price prediction, there are multiple kinds of inputs that people can take. One example or one thing could be the locality, right? Is it a posh locality? Is it near an IT park? Is it a suburb? It is outside city, inside city, right? That is a category, right? That is not numerical data. But with that, you can also put discrete data in it. That is, how many rooms or how many floors are there in the flat or building, right? That would also in some way impact the prices, right? With that, it will also be some factors which cannot be distinguished from numerical, like is which would again be categorical data. Are there some schools nearby? The answer would be yes or no, will not be how many schools, right? But you will be consuming all of it. But the answer that you need, it is going to be a continuous answer, because you are predicting a price. Price is what? Continuous or discrete or nominal, ordinal? It is a continuous data, right? You can have 1 rupee, 1.5, 1.25, right? So if you are predicting something that is continuous, you're talking about a regression problem. So you'll be building a linear regression, random forest, these kind of models, right? But instead of that, if you're talking about a, say, two categories. If the price of this locality is going to be high, or if this building is going to be high or low, you have decided, maybe some random number, but based on that, the final output that you need is yes or no. So that is two categories. That becomes your categorical output. All right. So again, if you're looking for categorical output, you would be building different kind of models, either logistic regression. Again, there are, you can build XGBoost, and there are different kind of models. Again, this is not a data science class, I understand it, so I'm not going to go deep on those models specifically, but just understand, different kind of data will give you different kind of inputs, and the output that you're going to have or want is going to decide what kind of model you want to build. But all this data, like numerical, categorical, both can be fed into a single model. But for time series forecasting and for unstructured data, there are different kind of model that would be built. Is it clear?
I think it makes sense. So basically, we decide what output we want, and on the basis of that, we decide like we will go what data we need to give to get that output.
Yeah. For the
Got it.
easier understanding, I would say yes. There are more
Okay.
nuances to it, but for the easier understanding, you will not be incorrect when you say it in a group. Okay.
Okay. Okay. Thanks.
All right. Any other questions on this? Because this is going to shape how we approach the next problems. Okay. If no question, then we'll move ahead. Okay. All right. Again, we are not going to go from A to Z, but on a high level, we'll try to understand, most of the terminology that is used. So people talk about supervised learning, people talk about unsupervised learning, people talk about reinforcement learning, right? These all are branches of machine learning itself. All right. The only difference is when you talk about supervised learning, you have labeled data with you, from that data the model is learning. All right. When we talk about unsupervised learning, you just give the model the data, but you don't give it, you know, any label. So when I say label data, what do I mean? From the same example, let's say we are talking about house price prediction. Okay. I give you 10,000, rows of data, and the final row tells you the price of that house, right? That is your target variable, or that is your dependent variable. All right. If I give you that, that is labeled data, where I'm giving you specifically from the past outputs what is the target variables value, right? If I'm giving that data and building models from that, that becomes your supervised learning model. Okay. So all the regression models, all the models that you would have heard about normally, XGBoost, gradient boosting, random forest, and blah blah blah, all those, if you talk from the enterprise term, or from an organization where you're working, our organizations are creating data every day and in huge number, right? So we already have that data, so we don't have to worry about giving it some data which is unlabeled. We already have labeled data for most of the problems that we have. That's why most of the problem statement in most of the companies are solved with supervised learning, because this is more deterministic and much easier to learn, because you already have similar examples to give to the model. Okay. Next is unsupervised learning. Now, what is unsupervised learning? Unsupervised learning is, you don't give the model the labels, right? But let it build classes on its own. So clustering, right? K means clustering, etc., are most common algorithms which are used with it. For an example, if I give, you know, model the data of 10,000 house prices, right? But I don't give it prices, all right? Or I don't give it a target variable that, what I'm looking for is prices, right? What it is going to do is it is going to divide that data into some classes, right? This algorithm, the calculations within it would do it in a manner that it would divide it into different clusters. So you can say A, B, C, etc., right? So if this is divided into multiple clusters, from that you can consider that there are, if it divides into three clusters, you can say there are three different classes, right, where the data is approaching. Four cluster, you would say four different classes, right? But there is no specific target variable that you have already provided it, right? So you're not supervising it. What do we call supervising? When you're telling something, how to do it. So if I tell it that if your house has four bedrooms, two floors, is near to a school, and in a locality where there's an IT park nearby, right? All those four different variables, then the price is say 10,000 USD, right? So that is it. It learned from the example that I gave it, right? That I've given you value of A, B, C, and D, and on that basis, I'm telling you the value of target variable is this. But if I've not given it the value of target variable, I've just given it the data, it has to decide how does it classify it, right? So I've taken a very simple example. So supervised learning is very easy to understand, right? You have labeled data. I tell you what is an elephant, what is a cow, what is a camel, right? You put it in the algorithm, it will see a new data, right? It will it would have learned from the past data. It can easily tell you that this is a cow, this is an elephant, this is a camel, right? But in unsupervised learning, you'll just give it input raw data. You don't tell it what is a cow, what is an elephant, or what is a camel, right? It will interpret on its own, right? It doesn't know it's a cow, it's a camel, or it's an elephant, but it would look at the features. Those features would be the data points that you'll provide to the model, all right? So based on those features, it will divide that data. If you consider, an X and Y plane, where X, so X and Y plane, it will put different clusters, right? These all three data points would go in different clusters. Based on those clusters, you would get different classes. And the assumption is, the if your algorithm is good, the calculation that the algorithm based on is good, the division would be pretty accurate. It would be able to give you, the differentiators, that this is a different class, this is a different class, this is a different class. The only thing is it wouldn't know, is it an elephant, what, it's a camel or a cow, but it would be able to differentiate it. Okay. For most of the organization, the data, the problem statement that we see is, I would say, mostly tilting towards supervised. Second is unsupervised, in certain scenarios. But the last one, reinforcement learning, uh, for all our purposes, you can consider it. There would be very less scenarios where you would be using it, right? Now, what is reinforcement learning? Reinforcement learning is when you provide a model an environment, all right? You just give it an environment, and you give it either a reward, right, or a penalty, and you're nudging it towards one output. You don't tell it what the output is, right? For an example, you would have seen a lot of videos on YouTube where a model is trying to learn how to walk, right, or how to stand up, all right? Now, what we have provided it is just a box, right? That's an environment. Now, each time each time it tries to, or it mimics something that is near to walking, right, it will, as an algorithm, you would be giving it a +1 point, right? And every time it falls flat, you'll be reducing 1 point, right? So what you're giving is, you're giving it reward for the action that you wanted to perform, right? It goes through loops and loops, after which it actually learns the final output. That is, it learns how to either stand or walk. The the most common examples which everyone would know about for this is, you would all know about the cars that are run without a driver, planes that would fly without a pilot, etc. So all those examples are of reinforcement learning. You have taught something, not by giving it a lot of data, etc. How you have taught it is, you have given it an environment, and the model will in itself learn by doing mistakes and you giving it reward or penalties. That is reinforcement learning. But for all our purposes, supervised and unsupervised learning models are mostly in picture, and they are used, okay, for most of the problem statement that we have in our companies. Okay, that said, everyone here would have either said sometimes that this is a model, this is a large language model, this is a machine learning model, this is traditional ML. But one question to all of you, what is your understanding? What is a model? What is a model actually? I would really appreciate if anyone would give you your view. What is a model?
Is it like an algorithm or kind of a code that determine like that runs what kind of output we want, like the intelligence that system has?
Okay, that's one answer. Yes, Pratibha?
Hey Saurabh, so what I feel is like model is something we create a set of algorithms and we set some kind of a task or the output to be generated out of those algorithms to get trained with the time, and then it works like of its own by providing the data. We do not have to every time write any set of equations manually.
Okay.
So
Yes, that's
that's
also
it.
a good answer. Okay. Any other interpretation?
Hello, sir.
Yes.
Hello.
Yes, Rahul. What do you feel is a model?
It is a copy of something that is usually smaller than a real thing.
Okay. All right. To some extent, that's also an answer. Yes. Ankita?
Is it like a structure or framework where we define the guidelines of how we want our not model rather, or how we want our structure to be created in terms of the input and output data that we give?
Right. So the only reason to ask this question, I'm not saying any one of you is wrong, right? But can you all see that there are so many interpretation to a term that we are using every day, right? What does that mean? That means there is some clarity which is missing. I'm not saying just one or two people, right? Even I was sitting one day and thinking, okay, everyone is using the term model. But if I generally talk about a model, what am I saying? Because there are machine learning models, there are Gen AI models, there are generative models, which there are multimodal models, there's time series forecasting model, etc. Right? So many models, right? But why is this term model specifically used, right? At the core of it, I'll give you one example. All right, and if you can relate to it, then I assume that for the rest of the period you would be able to take it with you, right? So uh, let's do this, okay? uh, let's take any calculation, right? In school days we would have learned about some mathematical calculation, like what is the formula for a plus b whole square, right? Does anyone know or remember that formula? Or okay, that becomes a little complicated, right? So let's go with a simpler one. uh, E equals to mc square, everyone knows about it.
Yes.
Okay, so that's a predefined calculation for something for you to understand, right? All right, like if everyone, okay, even simpler example, you all know about body mass index, right? So if you have a certain height and you have a certain weight, right, uh, I can decide from that calculation if you are overweight, underweight, or normal, right? We all know about it. So that calculation that is done for you is a model, right? So that formula that is created for you, that is a model. Now formulas can be, layered, can be very extensive. You can have, from A to Z, one layer on top of another layer, very complicated formulas, but at the core of it, it will still remain a formula, right? When you pass something through it, pass an input through it, you'll get a output from which you can relate based on the past learning that you have had. So how did someone reach to this conclusion that uh, BMI index of 71 is, of a normal person, and 80 is of a high, is a athlete, or 50 is of a, obese person? How people have reached to that? Because they devised a number considering, if your height is this, if your weight is this, right? Most of the people that fall, in the past, people have realized that most of the people that are falling in this category, they are heavyweights, they are, or they are athletes, right? So from that, you devised a calculation. That calculation is your model. So if you talk about large language model, there are layers of neurons, right? What they are doing, they're just calculating for you. That is a predefined calculation. From that calculation, right, you have devised a formula that is always going to work in a same manner, right? You'll provide an input, you will get an output. That formula that you create, that mathematical equation that you've created, that is a model. uh, is everyone able to relate with it, or I'm just, going bonkers with my examples?
Can you just like explain it again? Like we used to have theorems when we were kids, right? Where we used to have a medical formula and then there was calculations around it. Is it something similar?
Yeah, you can say that. So algorithm, again, what is an algorithm? Algorithm again is something of a calculation that you have devised, right? That will take some input and will be able to give you an output. That calculation, how you have reached it, let's forget about it. But again, it's again, what is it? It's a calculation that you've reached to, right? So it's a way of calculation, yes or no?
Yes.
Right? So the same thing is with this, right? uh, for any model that you see, when you are telling that you are talking, again, this is all in terms of AI that I'm talking about. If you go to for services, etc., there are also going to be model. Yes, Aniket, like a formula. There's an easier way for you to understand. This is, again, this is not for you to give to an interviewer, right? But if you understand on your own what am I talking about when I use this term, I'm pretty sure this would be very helpful for you to understand it better the next time that you use it for something, right? Okay. Any other question by anyone on this specific term? Okay. If no, I'll take the silence again as no. Okay. We'll move to the next one. So this topic at this point, which is going crazy, right? Everyone is talking about generative AI, right? So there are multiple forms of it, right? It, when I talk about generative, that specifically means you are generating something, right? If a model is able to generate something new, right, that becomes a generative AI model, right? Now it can generate text, it can generate audio, it can generate code, it can generate videos, images, etc., right? There are different implementations of it, but at the core, if I have to explain, if someone asks me what is gen AI, what is generative AI, the answer for me, it's going to be any model that generates something new. All right. And if you talk in specific, it could be text, audio, code, video, or images. Okay. All right. Now, within, but before this, right, one more question, because a lot of people get confused by this, right? So you all use ChatGPT, Gemini, Grok, etc., right? Is it a LLM, a large language model? You all, I'm pretty sure, would have heard this term, large
So,
language.
are you talking about whether it is a Gen AI or LLM? Because
It is
technically that
Gen
is Gen
AI.
AI. Right?
It is an Gen AI, right? But is
Okay.
it an LLM? Is ChatGPT an LLM? Is Grok an LLM? Is Gemini an LLM?
Yes, I think so.
Okay. Others, what is your view? Do you think Gen AI, I mean, more specifically, ChatGPT, is it a large language model or is it something else?
Yes, I guess.
Okay. Anyone else? Okay. Uh, I really appreciate if people would be more vocal, but that's okay, right? Even if you don't want to speak, you can chat as well. You can put it in the chat. All right. So, I mean, just to clarify, right? If you know it, great. If you don't, ChatGPT no more is a large language model. It started with being just a large language model. What is a large language model? It would be able to understand, the normal language. It's called large because it's been trained on a very, very, very large data set. All right. But it now not only takes text, it takes audio, it takes code, images as well. Not video at this point, but I'm assuming in, very soon it would work on that as well. So all those models which are now able to take more than this form, they are now called multimodal model. All right. So even ChatGPT now is not a large language model, it's a multimodal model. Okay. So now coming
Just
to,
before we move on, so you're saying like large language model only takes text. So the text that model which works on text would be LLM, is it?
yeah, the reason why I said this was because definitions are now changing, right?
Okay.
So it all started with large language model. Everyone's talking, it all started in 2017 when transformers architecture came in picture, right? With a very popular, I think everyone would have heard about it. If not, then you can go and read about it. uh, there's a white paper produced in 2017, if I'm not wrong, that talks about, the headline for it was attention is all you need, right? That was the transformers architecture on the basis of which all the LLMs are created. Okay. So since then, we were talking about large language model. It started with small language model because it was trained on small data, then became large language because it was trained on, very large set of parameters. But now it doesn't only take text, it understand much more than just text. So it's no more a large language model. Okay. Your But in the production, if some of you are using ChatGPT's versions which do not take other forms like 4o, etc., right? In production we also have those, right? So those are not multimodal, those are still large language models. Okay. All right. So there are a lot of terms that are coined with this thing, LLMs, right? Let's talk about those terms now. So first of all, tokens. What is your view? What is a token? Okay. the other classes which I take, right, where most of the people would be freshers, I have to sometimes nudge them to speak, right? So it seems it's going for you all. A unit data used to train model or even pass on as an input. Okay, all right. So we are talking more specifically in terms of language models, right? So in that term, I mean, your answer is bang on, right, Akanksha? But for everyone to relate and to understand, right? Tokens are, it could be words, it could be subwords, right? But from the words that we speak, right? The text that is generated, that the models are using, right? For the same text, it can take it in different forms, right? It could take the whole word, or if it's a larger word, or even for smaller words like up to 4 or 5 letters, uh, we realized with time that models learn better if we divide them into smaller words, so that what happens is some unknown terms that they wouldn't have heard about, right, they would still be able to relate it to those terms, right? For example, if I would have trained all the models, all the LLMs, and told them that you know these each word is a token. Yeah, Niket, I'll come to it. Okay, so each word that you take in, that is your input. Whatever you're building, you have to build based on that, right? The problem that would have arisen with it is they couldn't have become that intelligent. For an example, let me tell you, right, how we use our language, right? We, you know, we engage in language in terms that humans assume that the other person would be able to understand if things built on top of the new existing things. So if I could say chat gpt fied it, you have chat gpt fied it, right? Or you have gamified it, right? If I would have only taught it from Oxford Dictionary, that term might not be there, right? But because it learned with subwords, right? So words, then subwords. Subwords could be GAM, could be one word. EFIED, right? EIEF and IED. So slowly, because it would have seen so many examples of those, with that it has learned that if it gets a new word, right, where it sees game, it would be able to relate it with the other examples where the game word would have come, right? And if you then use it, fied it, if it would have seen classified, and because it has been able to break it into different words, it can now relate gamified with game and classifieds fied. So it realized, okay, so this is a different word. Okay, yes.
Sorry, I was speaking on mute. So, is this the intelligence of the system? Like, these are
No, no,
like intelligent
no,
systems,
no.
no?
Again, I'm just reaching to a point, right? I'm just explaining token, why tokens were not devised at only words, right?
Okay.
So
Okay.
tokens are not words. Token are not even subwords, right? Externally, if you ask, right, even if you go to chat gpt 5, right, if you tell it, if you give it a stanza, say 500 words or 600 words, and ask it with all of certainty, can you tell me if this is the amount of text that I'm giving you, how much of token are there against which I will be charged, right? It won't be able to give you that answer. It will give you a relative answer, that approximately these number of tokens. But the way the model has been trained, right, there are multiple ways of embedding while you're training a large language model. So the way that specific model would have been trained, right, that defines for you what is that token. But for an easier understanding, because the pricing is one challenge which most of you being leaders would be dealing with, right? So if you are dealing with prices, if if you are bringing in an LLM for an existing problem which you are currently solving with something else, maybe with a traditional machine learning model or with a deterministic code, right? Whatever you're solving it with, if you're moving towards a language model, you have to understand how much of text it is going to process. And if it is going to process this much of text, this is going to give me this much of bill of the number of tokens processed. Okay. So the pricing is there. If you go to Azure, if you'll see the pricing for Q. If you go to AWS, you'll be able to see prices for different models. If you ChatGPT O3, other than that as well, you can use Claude, etc. Every of those model is billing you based on the number of tokens that are processed. Okay. Again, I'm using the word processed because it's not used, it's processed, what they are processing with for those. In some cases, if you devise a good system, you don't have to process all the text that you're providing. Like for RAG, you don't process the complete document that you give. Okay. All right, I hope that on a high level at least you get an idea about what token is. All right, now parameters. All right, I'm pretty sure someday or some form you would have heard this term, because when the models were growing, right, this was the talk of the town. ChatGPT 3 is trained on 50 billion parameters. Then came ChatGPT 4. Oh, it is trained on 1 trillion parameters. Then 5. Now the count is lost, right? Quintillions or whatever it is, right? So what are those parameters? But anyone has any idea what are those parameters that we're talking about?
These tokens and its meaning, like permutation and combination of these tokens.
Sorry, permutation and combination as in?
Like what combination these tokens can have, like these words can have.
Okay, not exactly. So Akanksha says variables. Yeah, to some extent, yes. But again, variables for what, right? That's question. Any other interpretation?
Could it be a kind of data or a category or something to define data to a deeper level so that like multiple scenarios and stuff?
All right,
Not
okay.
really exactly.
Uh, all right. See, there is some mathematical calculation going on here, right? Uh, Again, if I have to explain the complete transformer architecture, it will take a few hours, but I'll give you on high level, how an LLM would work, right? So instead of LLM, right, just go to the architecture on which it is built, right? So it is built on transformers architecture. Okay. So let me just give you a view of the transformers architecture. Let me know if you're able to see the transformers explainer now. Hello.
Yes.
Yes.
Okay. Okay. All right. So this is your input. All right. This is how a transformer architecture, or again, which are on the basis of which all the LLMs up till now are built on transformers architecture, right? So this is how a transformer or an LLM in general would process your input to provide you an output. All right, let's see one by one on a high level only. Look, I cannot go in deep because these are very extensive topics. Each of these layers are in themselves a very extensive topic. Okay, so once you enter any word, right, the model would have seen this word in n number of cases, right, while it was trained on billions of data points. So suppose at this point the 5.0 or the ChatGPT 5 or even the larger models from Perplexity and Gemini, they are trained on the complete data of our internet, right? So all the internet data they have gone through. All right, so now if they've gone through the whole data, they would have seen as, say, millions or billions time, They would have seen the millions times. They would have seen spaceship million times, was a millions times, approaching millions times, a million times. All right. So how an LLM would work is, for the input that it takes, all right, what it does is it creates an embedding for each word that is there. All right. So it first converts that word into a token. All right. So once it has that token, all right, this again, from the training perspective, it has already seen that word. So every word it has seen, it creates a matrix for it. All right. For example, if I talk about, model would have seen Sachin Tendulkar, right, multiple times through the internet, right? Then what happens? If it's a smaller model, it would have been trained on, somewhat uh, smaller data set, right? So it would have heard about Sachin Tendulkar a few times, right? So if whatever times it would have been learned, seen it, it would have learned those traits. For an example, if I talk about a small language model which have gone through, some training, it might know that Sachin Tendulkar, when I talk about, I'm relating him to cricket. All right. Now, cricket has its own parameters, right? So it has batting, bowling, fielding, etc. Now, Sachin Tendulkar is also a male or a human, right? So if I talk about a human, we have different traits. All right. We have two eyes, nose, lips, head, ears, etc. All right. That becomes a different category of parameterization. Then he's a male. So male have, some biological differences that would also come in picture. Now, if you talk about even larger model, right, it could also relate to that. Okay, Sachin Tendulkar is father of two children, right? So understand, the longer it would have, it would be able to consume that information, and it would be able to create calculation, some embedding for it, right? That it could use when sometime, or in the next time it sees a similar word. All right. So if it sees as, it would be directly able to call that embedding that would have been created while the model was trained. Okay. So that is a calculation it is going to bring in. All right. With that calculation, when the model was trained, it would have learned those patterns, right? So as many patterns it would learn, right, about a person, those patterns are the parameters. All right. For each uh, word it would have gone through, for each word, the related things it would have learned, those are the parameters that we are talking about, right? It's not that, Sachin Tendulkar specifically who is it, right? But in general, a father has children, right? Father's age would be larger than children's age, right? What is the physiological or biological difference between them? There would be something in the data that would have seen in different times. From, it's almost like knobs, right? You have your, tabs, घर पे सबके null होता है, right? So you can consider that it would have, fixed those tabs at some point for each embedding. So that is what we are talking about when we are talking about parameters. Yes.
So, can we say, like, for example, if I hear something as a human being, I relate it to 10 different things, which is mostly assumptions, right? Not some assumptions, some data, but I kind of context that is set because I can hear something as a human being. Is what is being kind of replicated here? Like,
You can say it, right? So smaller models would not be able to gauge, gauge that much about something as the newer model that have been trained on larger data. So similar to us, right? If you talk to a child, right, if you tell them about, uh, if you tell them you have to go to a bar, right, he would not be able to relate it to a, liquor bar. He or she would relate to a chocolate bar, right? Because that is the data that it has seen, right? But if you talk to a person who has gone through more data, right, like us, if you talk about bar, we might be able to relate it with chocolate bar, we might be able to liquor bar, we might be able to, something else as well. But because you've gone through that data, you've passed through that data, so you have those parameters, those knobs changed for you. Okay, does that help? Yes, no? If it is not helping everyone, right, it's just me speaking, not going to be very helpful, right? Was it is it easier for you to understand now what parameters we are talking about when we say, you know, a model has been trained on X number or Y number of parameters? All right, okay. But if you're not able to understand, ask questions, right? If you understand, great. At least, you know, give a thumbs up or something, right? So that I understand, okay, you all got it. Great, all right. Thank you. Okay, cool. All right, so the next next is embeddings, right? So embeddings we've already discussed, right? So these are uh, the matrices or matrices that a model creates while training for each word, right? That it can call off when a new input is given to it, right? So those are the embeddings. So you can consider it, you know, a vector form of your textual data. So your text says Sachin, its vector form would be, you know, uh, n cross n matrix. So, you know, there's that many number of layers or layered matrix. All right. So that is your embeddings. Next is prompt, right? So prompt and prompt engineering will go in the next few slides. The last thing which, you know, a lot of times people do talk about is fine tuning. Anyone understands what fine tuning is, and what is your view of fine tuning?
Can you pardon?
Correcting data.
Hello.
Can you repeat the question once?
What is your understanding of fine tuning?
Is it correcting data?
Correcting
Probably
data.
training it more and to nourish it to give the proper and good output, like the
Okay.
correct output.
All right. Okay.
Maybe a
Uh,
more like furnished one.
okay. All right. Uh, I'll need at least two or three more answers so that, you know, I could cement that people have different understanding of fine tuning. None of your understanding is wrong. It's just that these are terms everyone uses, builds your own view, but don't actually dig in to understand it, right? Yes, Ankita.
Refining it a little bit more,
What
providing
again?
additional
So
parameters to create the structure.
so you have used a lot of you know, vague terms.
Yeah.
Right, so that's why, you know, the reason to specifically talk about each topic is, instead of talking in vague terms, we'll try to understand what it is doing and what is it, right? So okay, so that is cemented that, you know, people have different view of fine tuning. Someone used the term training, right? You cannot train you cannot train a large language model, right? You don't have the infrastructure, your organization doesn't have infrastructure. If I talk about my organization, it has a revenue of 6 billion, right? It's a medium. If I'm thinking about creating my own LLM, right, uh, it would surprise it was you know, what it's called, it would surpass the value of the revenue that the organization generates, right? So at this point, we are not going to train a model, right? But you can fine tune an existing model. Most of this fine tuning is not used for large language model, but used for small language model. In today's age and world, if you see, because, you know, the field is now maturing, right? So most of the problems that people are trying to solve within their own industry, they are trying to solve it with small language model, right? Your llama 3s, your say phi 4, phi 3, etc., right? So these are small language models. They have been trained on much smaller number of parameters, but their still their understanding of language is good. They would be able to give you good output, right? But why to use them, right? When you have a large language model that is going to see much more, that has more knowledge, right, would be able to give you more answers. The answer is, for your specific problem that you have, right, you want answer for your problem, not the billions of the rest of the things that the model knows about, right? So if you talk a small language model, right, and you are going to ask that model specific things about your own industry, from my perspective, I could say, if I talk about legal industry, if I use the legal terminology, or I ask the model to use the legal terminology, understand the legal terminology, it might not perform as good as a generic, as it would perform on a generic problem statement, right? But I would want it only for legal terms or legal knowledge, right? So what I can do is I can fine tune it. What is that fine tuning? There are multiple methods: LoRa, Q, LoRa, etc., etc., right? But again, we don't have to get into those things specifically. But what happens when we fine tune a model is there are weights and biases, all right, within each model that it is using in different layers that I've shown you, right? On transformers, there are weight and bias in each calculation, right? If you fine tune it, that means you give your own set of data, right? And with that data, with those specific techniques which are there, you would be able to fine tune those weights and biases for your own problem statement. That is much cheaper. If you are going to fully retrain a model, you are only going to partially update some weights, some biases, that on that basis some calculations within the model would be updated, so that when you use that model, that fine-tuned model, it would be giving better answers. Yes.
So as per me, we can only give prompts to LLM model, right? So how
Yes.
will you train all these, like manage all these biases and everything?
Yeah. So that's why there are different techniques for it. All right. uh, as I said, like LoRa, Q, LoRa, etc. There are multiple techniques. These are not the only, right? You can fully retrain as well, right? But that infrastructure cost would be very high, even for a small language model. We have recently fine-tuned one model, right? It is taking us more than almost a year to take it to production. Uh, but tuning it was almost like it took a few months of GPU usage, right? With the specific techniques that I specifically talked, because those are techniques which we used, right? But there are multiple techniques that you can use. I'll have different sessions on GenAI after that, when we can go more deep and on those technical aspects. Here I don't think it's needed. Okay. But for your purposes, you can understand the existing model. It changes its weights and biases in some calculation that is using, so that it would be able to give you the answer on the data that you have provided it for fine tuning. Again, don't use the word learning, because you cannot retrain it, right? You're just fine tuning the existing model. All right. All right. Any questions on fine tuning?
So this is not exactly training, but it is like controlling a bit of what they say, what the answer could be.
Yeah, you can say that. So you make it more specific towards your own problem statement. So one line which you can take for fine tuning, right? It's like giving an AI some extra training, so it becomes an expert in your domain or task. That's it, right? Let me just put it. Yes, can fine tuning be a help in fixing AI mistakes? So okay, hallucinations and all those things, those are intrinsic to the solution that comes with the Gen AI models. So because that comes with the solution, it's not a problem that could easily be solved. You have to devise new ways to you know uh, train a model. One, there are certain ways if you're using some models with prompting, there are multiple ways of prompting that we are going to talk about just after this, with which you can reduce those mistakes, right? But just by fine tuning, you are not going to fix all the mistakes, but the correct understanding would be for your own specific domain, the answers that you're looking for, it would be making less mistakes on those answers, right? So if that is what you're trying to say, absolutely correct.
So is it like providing context? Is it?
No, 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 no. Context is a
Making it
different thing.
smarter probably to
Again,
answer.
yeah, it's not, again, you're not making it smarter at all, right? It is whatever
Mm-hmm.
smartness it has, it would remain. It
Okay.
just, okay, suppose you have no idea about legal terminology. I'm just considering that you're not a lawyer or an attorney in US, etc., right? You have no idea about it,
Agree.
right? But you do know English, right?
Agree.
Okay, so if I ask you specific terms from that part, right, whatever legal terms there are, right? So I'll throw some terms at you. You might not be able to relate it with the existing English that you know, correct?
Yes, agreed.
But once I give you some data, right, that would give you an idea that you can relate A term to B term, right?
Mm-hmm. Yeah.
In that way, you would realize, okay, okay, I knew it. So how do we learn anything, right? We are only talking in English at this point, right?
Correct.
So if we are talking in English, we are learning it. All these terminology that we have talked today, you are not knowing it, or some of you knew, some of you didn't, right? But just because you have that base understanding which a model would have, right, on top of that you are relating it with your existing knowledge. You're not, it's not that those terms are doing something which is out of this world. We have only coined those terms which is relating to your existing knowledge, right? So that's what you're doing. You're telling it to relate it to the existing things that you know, so that it won't feel this is unseen data for it. Does it make more sense?
Yes,
Okay,
completely agreed. Thank you.
good. Okay. Okay. Then this proves them little more intelligent. All right. All right. Okay. And let's move to the next one. I'm going to spend very less time on this one, more specifically, right? This is evolution of large language models. But how the large language models have evolved. Uh, so it's not that AI was not there in 50s, 60s, etc. The first perceptron, which is called a single layer of neuron, right, it was devised in 1950s. All right, since then we are step by step moving towards what we call it AGI, artificial general intelligence, when the assumption is that AI would become more smarter or more intelligent than us, which I really believe at this point it is, right? But still, this is how it has progressed, right? So initially we have perceptrons, then came neural networks, right? The problem with perceptron is because it has almost no context window, right? It has no way to you know keep some meaning of a larger set of input. All right, so that's why perceptron was but again at that point it was all mathematical. The computers had no power, etc. So for that purpose it was okay. Then came neural network, right? So they, instead of just one layer of neuron, right, it had multiple layer of this perceptron, you can say, right? So multiple layer of neurons were built, right? So that becomes a neural network. All right, so each of those neurons had some calculation you're passing your input through, right? So that's how it is able to sustain that knowledge. All right, then came RNNs and LSTMs, which are built on top of that. So that is recurring neural network or long short-term memory. So until neural network, the memory was pretty much not there. If you are going to put a longer sentence, while answering, it will forget about the previous part, right? So that problem was to to some extent was reduced by LSTMs or RNNs, right? They use different gates. So LSTM uses forget gates, remember gate, etc., to just tell its model what to forget, what is the meaningful information, what is not, whatever is not, it will put it in forget gate. but whatever is meaningful, it will keep it. All right. Then, as we talked about in 2017 approx, came transformers, which is self-attention mechanism, right? So it has, thousands of layers of those neurons, right? Or neural networks, basically. When you pass your input through it, or through it, and you train each neuron with certain parameters and certain calculations, you're changing those calculation, it becomes more intelligent. And it's not doing it in a manner that, it's sequential, it's parallelly learning about each word that you input. All right. So that, as we discussed about transformers, so I'm not going to again go into it. The future, right? So up till all the large language models were using transformers. Now the next thing is state space models, Mamba, right? So this is going to, you can say, be in industry in next 3 to 5 years, or maybe, next 2 years. I mean, at this point, wrapping around our head of how fast the technology would move on is very hard. So, but this is what is going to be the next thing, right? At this point, this is not there, so there's no point in, going deep in it. But just for a highlight, this is how the large language models have processed. All right, from 50s to now and beyond. Okay. All right. So, little about the families of different models that we have. All right. So, we have GPTs that comes from OpenAI family. Again, I've used the word multimodal. And now I'm pretty sure everyone would be able to relate why I use the word multimodal, right? Because it does not only text or works with text, it works with images. That is, it can generate images, it can generate audio as well. I mean, these days, whatever I have to learn, I don't chat with it, I talk to it, right? I talk to ChatGPT. It's very quick in, converting the text into audio. So I don't have any lag at all, right? So that's why it's multimodal. Claude, whoever is using Anthropic's Claude, that is good for reasoning or your coding, right? That's because it's a specific use case. It's been fine-tuned specific to do that task. All right. Again, Quen is by Alibaba. That is general purpose open weight. That is, you can fiddle with its weight, right? You can fine tune it as much as you want. It's again openly available. All right. Then comes Llama, which is by Meta. So for most of the research use cases, right, Llama is used. All right. Again, you don't have to have a subscription. You don't have to pay for APIs, etc. Again, for whatever use you will do, you'll pay. But for whatever research, etc., you want to do, this is much better than the other models. Okay. Again, Gemini, it is again multimodal. DeepSeek, I am pretty sure you would have heard in, I don't know, I think last 6 months or so back, DeepSeek became a household name because it was, the performance that it was giving was to some extent was near to the ChatGPT's model, whichever was there. I think it was 440, right? But the difference was that the amount of money spent to train it was 1/50th or 1/60th what it took for ChatGPT to reach there, right? Then the last one is Grok. Again, it's conversational, but the different thing about it is because it's with the owner of X, right? So it has web integration. You actually, talk to it about what is going on in internet. All right, and more specifically on X, right? So whatever data is there on X, it has learned from that as well. So it becomes a little more specific, right? My own understanding is, for most of my purposes, at this point, I think ChatGPT is better than most of the other models. Yes, Pratibha?
Do you have any opinion over this Indian initiative, Sarvam AI?
No. I okay, I did I write a lot to our, you know uh, government. I wrote a letter when, Perplexity gave that free plan, right? for all Indians with Airtel. That day I wrote a letter to our Prime Minister saying that this is the end of open knowledge for India if this becomes because that's what I feel. If Perplexity is not an Indian company, it will have all our data because again it's free, we'll use it. Now realizing that thing, OpenAI has also given its Go plan, right, which costs 399. It's all for free for 1 year for all the Indians. Why do you think it would do it, right?
Marketing strategy.
Yeah, so we all would become hooked to it, right? And with the data that we are providing, no one generates the data amount of data that Indians are generating at this point because again, free and cheap internet, right?
Agree.
So it would learn about us with all the different technologies that have come in at different stages, right? The problem, the benefit which India took was because those were outsiders. They were not able to localize the technology. That problem is not there with AI, right? If you talk to it in Hindi at this point, it understands everything. If you talk to it in Tamil, it would understand everything, right? So that localization factor is gone, right? And as late we are going ahead with our own initiative for this, we are losing the race in a manner that we might never be able to catch up again. But I would still say they're not Sarvam specifically, but there is one more initiative which the government, I mean, I got that information from PMO. It's that portal itself against the letter that I wrote, that they are working on one model, again a general purpose model, which would be to some extent you can consider it related to ChatGPT 3, up to that extent. Even if we get that, that would still be a good starting point for us, because tomorrow if everything moves towards this, right, and you stop with your if these countries stops us from utilizing Perplexity, GPT, etc., whatever industry has utilized them would be dead in a day. Similar to what could happen if all the apps that are there on App Store or Play Store for Google or iOS, these both are US companies, if there are some sanctions on us someday, whatever application, whatever companies that are running on those applications, your Mindras, Flipkart, etc., all will die in a day if they are moved out of that, right? So I
Agreed.
do feel I do have a view, but not on Sarvam, because I don't think there's anything there. Okay, all right. So this was just on these one. My personal favorite again is ChatGPT. It in general purpose, ChatGPT 5 is the best model at this point, at least whatever I have used. But there are other models which are way better, but they are paid models, right? So which I talk to everyone about. I'll post it in the chat. You can try it if you have money, right? You can use it, and it's pretty much like a senior consultant, senior developer, and a senior technician in your company. It would do everything. Most of these models, right, your Gemini, Chat GPTs, are pathetic at building PPTs, right? If you go to GenSpark, take their free version, you will be able to create one, but give some details about what kind of presentation you want to give, and just leave that prompt for 10 minutes. It will give you the your life's best presentation that I think you would have taken like if not weeks, then at least days to create. Yes.
Have you used anything here for this presentation?
For few slides I did. For few slides, like this slide, I didn't, because PPT already provides, that MS PPT already provides a lot of customization, so I didn't have to do much. The designer gives it. But for certain slides, let me see which slide was it. So this slide was created completely by Gemini, right? But I had to give multiple prompts. But GenSpark, again, it's a paid model. I have exhausted my subscription of it, so couldn't use it. Otherwise, I would have definitely used it. Okay, now the last leg of it, prompts. I'm pretty sure most of you would be interested in this part because it's going to help you a lot. All right. So with that, let me just open. Okay, all right. So I'm assuming that every one of you would be using prompts every day at this point, yes or no?
Yes,
Right.
definitely.
So what is a prompt? I don't think we have to you know dive deep into. You all know, right? Prompt is in your own language, whatever input you're putting, right? Whatever text input you're providing to your model to get an output, that is your prompt, right? With a prompt, you can instruct it, you can put some constraints, whatever it is. So all those instructions, it what is your prompt, right? But then what is prompt engineering?
Can you repeat, please?
What is prompt engineering?
To fine tune the prompt, I would say, to learn how to re-engineer to get it more specific to the so that you get the proper outputs, because what we write exactly does not always give what we are looking for in a
All right.
certain
Okay.
syntax and format.
Okay. So
Maybe
basically writing better instructions for the model so that you can get better outputs, right? With less mistakes.
Yeah.
All right. So you would all have heard about prompt engineering. Some of you would have done it. Some of you would, would have searched about it. In whole of it, this slide gives you pretty much everything there is to know about prompt engineering for a, you know, even up to a prompt engineer. I think if they know about up to this much, they know they are pretty much a prompt engineer, right? So let's start with a basic one. All right. The most basic prompt that we do, right? We just give a prompt to our model, right? We don't give it example, we don't give any instructions with it, right? So that is your what? Zero shot prompt. All right. So if you all can, I mean, if it's possible for you, if you have multiple windows, you can all try these things which I'm going to talk about right now. Okay. So for zero shot prompt, right, you can consider it something like, I got the job, but now I have to move away from my family, right? This doesn't give it anything, right? You don't ask about anything, or even if you're asking about anything, right? If you say, I want to tell, I want you to tell me what is going to be my emotion, right? If I feel this, and then you can write your sentence, I got the job, but now I have to move away from my family, right? It might be able to relate it a little better, right? But what does few shot does it, you give it examples, right? If you give it few examples and then ask it to work on that, right? So I'll give you one prompt, right? Just try it in your own versions. All right, so whatever model you use. Where is the chat? Can you try this? Now, if you have tried it, right, and if you get a better answer there, right, try it without it, right, without giving an example, and then just write a different sentence, right, on maybe on a different chat window or with a different model. You'll realize just giving some examples makes it, n times better. I don't know you guys are trying or not. At least just give me a nod, yes, no, anything. Hello, am I audible or not?
Yes, yes, yes. I was just trying. So I tried two prompts, one with the example, another one without the example. So I think with the example, it is a bit better.
Right, so that is called few shots, right, where you give it some examples. All right, then comes your reasoning techniques. All right, so if you don't know, the worst performance that you get from a model is on any of the reasoning questions. All right, for an example, if you ask a model about similar reasoning question that you used to get during your those days when you were either preparing for some examination, it could be engineering, it could be something else, right? So those reasoning questions are the hardest for a model to do, because when it comes to calculations, right, it's mathematics, it's not it's their strong forte, right? So what happens is, if you ask it, okay, if I give you $10 and if I give person A $5 and this person gives you $2 and then that person rounds out something like that, right? It will lose the context because it has to switch between mathematics and not mathematics. It's not able to do, right? So it is trying to do mathematics with English language, right? So that's why reasoning is not its strong forte. So if you have a reasoning task, how would you do it? All right, so there are multiple techniques that could make it better for you. All right, so one is chain of thought. All right, so that is where you're asking the model to show thinking steps to solve reasoning tasks, right? So prompt could be, show your reasoning step by step for a problem. Now the problem is, if a pen costs rupees 10 and not notebook costs rupees 50, how many pens equals one notebook's price, right?
Hey, hey, can you do me a favor if possible?
Mhm.
Instead of these prompts, maybe in parallel, can you open the chat GPT window and if you can try it out? I have to go back and forth, that's why.
Okay, all right. Let me. Okay, so that's actually faster. Thank you. Okay, so it's actually showing you the calculation, right? But if you wouldn't have asked it for the showing the calculation, it would directly try to give you an answer, right? So what would happen is, if it tries for this calculation internally, it is reprompting itself, and then there the validation parts comes, right? So it is actually validating while giving you that answer. Okay, so if you can see, the answer is correct. All right, then the next thing is meta prompting, right? So in meta prompting, we don't give the content, we give format, rules and structure. All right, so when I say format, rule and structure, it is like telling it in what format I want an answer, right? So you can say like this: reply in this structure only. What is the concept? Concept is something, right? Whatever you will give, right? Then real world analogy, it would give one line explanation. So you've given it the structure that you want your answer to be, right? Then it would perform comparatively better. Okay, so if you can see the topic you have provided, it will give you concept, real world analogy, and one line explanation that you can use at a lot of places, right? So that is what meta prompting is. Next is self consistency prompting. Again, I'm not, it's not that I remember all those terms, it's I'm using from here only, right? So self consistency prompting, what self consistency prompting does, it instead of one chain of thought, right, it asks AI to follow multiple paths, right? So path A, path B, and path C, and then answer with the best one, right? Whichever it feels is the right one. So what happens is internally it is creating three different answers and validating against each. So hence the quality of the answer becomes little better, right? So for an example, so it has divided it into three different methods, all right? And from those methods, it has almost like voted what method is correct, all right? So you can see if just we ask it to think in different manners, right, its accuracy increases. So that's what we want to do, right? Next is general knowledge prompt, all right? So let's try that one as well, and then we'll move to the next topic. Okay, in general knowledge prompt, what you'll do is you'll first ask AI to generate background knowledge, all right? Then you'll ask it to generate the answer, all right? So it actually generates some content which was not there, and then on that basis it is going to give you the correct information. So if you'll see it, right, list all facts about humans need sleeps, and then answer why do we feel sleepy about long hours. Because what happens is it first bring in all the or most of the data that it had stored about humans and sleep, all right? Then it is going to be looking at specifically that data that it have fetched for your answer, right? Then what happens is it becomes more related, right? It becomes more targeted answer. All right, so again, if you can see, it first generated the facts: sleep supports brain function including memory, consolidation, etc., and then the answer: why do we feel sleepy after long work hours? So what happens is after long work hours of mental or physical work, blah 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 blah. All right, now for all these techniques that we have discussed, right, I'll share with you the prompts, all right, in a document or something which you can use and utilize this, right? So this is, again, it's not a rocket science, it's just the way you're prompting and what is the thought behind that prompting, right? That's it. Any question on this? I would at least hope some questions on this one.
Hi, Saurav.
Yes, man.
I have one question related to this. I have seen that there are several add-ons available where they help us in writing the right prompt. So
Yes.
eventually, whatever knowledge we have, we put it in the tool, and that tool help us in drafting the correct prompt, and then we can put that prompt and get the answers.
Yes.
So, is there any specific tool available in the market which can help us in how to write the perfect prompt? For example, you have given these samples and techniques, right? But
Hmm.
still, when actually in future we want to apply this for a real-time scenario, then it is very difficult to remember which technique we need to apply. So, is there a way to figure out which
Yes.
can help us in identifying this?
Yes, there are 2 or 3 open source tools which are available, right? uh, the only problem is, right, if you are going to use those tools for your prompts, right, you'll have to provide some data with it, all right? So if you're using it for general purpose or mass data as well, that's okay, right? But if you're using for your own enterprise or your organization, right, that becomes a little challenging, because there's a possibility of data leakage, right? Again, those three tools, I think two which are most commonly used, which are very good, right? If you give it, on a high level what you want to do, it would create the best prompt, and it will also give you the percentage accuracy with it, right? So maybe 80%, 90%, or how much it has increased from the prompt that you have provided. Accuracy, how much it would have increased after the prompt it would give it. It also gives you that number. I'll provide that as well, with that documentation for this prompt. Hope that works.
Sure. Thank you.
Okay, but
Okay.
again, yes.
Sorry, I was just telling that there's one more thing that I tried. It worked like a little bit. So I was using GitHub Copilot for some prototype applications, and I used ChatGPT to give me prompt that will work in GitHub Copilot. So I gave some context, and that actually worked. So I asked ChatGPT itself to create a prompt for another application.
Absolutely. All of these models would be able to generate good prompts for you as well, right? But just to tell you, if you're creating an application for production use, right, uh, the prompts that you would create more often than not would be a little different from the prompt that you would use in general, right? So if you're using a prompt in a code that would generate some output for you, that was again being used by some other prompt within a code, the kind of prompt needs to be written is little different, all right, compared to this one. So again, chat gpt, copilot, etc., all are becoming so helpful day by day. You can definitely ask them to correct their prompt as well, right? If you write something and you can ask, okay, this is my specific problem, what should be the prompt, they would be able to give you. But these all work for general purposes. But if you're going in for production environment, it always helps to know about what kind of techniques would be little better. Okay, that said, there are already are multiple libraries, right, which give you a lot of guardrails for protecting your data, and multiple roles as well that you can create for the kind of agent you're building, etc. So don't get into agent now. I will talk about agent in some time. Yes.
So these guardrails are part of prompt, or again, this is again something that is trained by
there
to
are
the
there are
system.
multiple ways or multiple things about guardrails. Again, that would become a very lengthy topic in itself, right? So guardrail comes mostly for the security of your data, all right? So there are few ways which I can tell you pretty easily. The way you take the endpoint from Azure, from AWS, etc., right, while you're purchasing that endpoint, right, or procuring that endpoint, there are multiple configurations that you have to select, right? From those configuration as well, you can you can disable obscene data, pornographic prompts, abusive prompts, abusive words, etc., that you can do there. With that, there is still possibility that people, malicious user would use certain prompt in your application as an input that could still bypass that. So what you can do then is, in that scenario, while you're writing your prompt in the code, write two prompts. Most of the people does it, right? One is going to be a system prompt, and then your agents, your inputs, etc., all those prompts. So system prompt should give you all those things where you're putting in, okay, do not respond to an answer, or do not divulge or give the internal application information, right, when asked about. Do not give anything other than this set of data that I'm providing you, right, etc. And the other guardrail that becomes is, whatever output you're getting, right, validate that output with another prompt, all right, which you already give a specific data that it should not be having this data, or it should be having only this much of data. If it goes beyond that, you should give an error, or output in a manner that it says that you are doing something incorrect. Okay, multiple ways to put those guardrails, but there is not just few guardrails. At this point, there is so many malicious activities going on that you have to put at least 30 or 40 different guardrails at different points, even at the input side as well as at the output side. On a high level, that's the answer. Okay, before going to this, right, I hope one thing which would be very helpful for everyone, right? So let me do this for all of you. How many of you know about how to utilize any model or any of these APIs that for these models we have been provided with your code and be able to do better things? I'm pretty sure in every organization, you would have AI engineers or data scientists. By now we are working on different POCs. They would be using your ChatGPTs, your Groks, your Geminis, but not with a user interface, but they would be using it with their code. So we'll take a small example. How do they do it? All right, again, this is going to be an open source example. There in your for your application, etc., you will take it enterprise version of those models from Azure, AWS, whatever, or maybe directly with OpenAI as well, and then use it in your code. So the benefit with enterprise version is your data remains in your own environment. It doesn't go to retrain the model, or your model. It's again, you don't know it, right? But you have a contract that saves you, right? That this data will not be used for uh, retraining the model or fine tuning the model. So your data remains in your organization. All right. Okay. So how many of you have actually built, an agent or something with any of these models?
The question that have we used in Open API in any of the prototype or something?
Yeah, you can consider that to be the question.
So I don't know if it is an answer, but yeah, I try to use like in GitHub Copilot. I try to create a kind of a prototype using API, and for that we have used Open API key. So I think you have to register and get the key.
Yeah, so that's what I'm going to discuss now. So good starting point, right? So to everyone, if you have ever thought that, okay, how do we do it, and you want to try it, let's do it together. Okay, so this is one of the keys which I have created. Okay, you just have to go to platform.openai.com API keys. All right, I'm assuming all of you would have a ChatGPT registration by now, right? The free one. Again, go log into that. All right, now you have to purchase a key. All right, so for purchasing, you have to the good thing is it is pay as you go. You don't have to buy a subscription, so go for pay as you go. Just load it with few dollars, right? Again, you'll go to platform.openai.com API keys. You'll get every information there itself. All right, once you load it with few dollars, right, come to this specific page. All right, there you have to go and create new secret key. All right, this is just your name, whatever name you give, right? And once you give that name, you have to choose between permissions: all, restricted, or read only. Okay, so because you are going to just try it, you don't want it to be very restrictive, so you can use all. All right, and once you click on create secret key, all right, it will generate a key for you, right? But the first time it generates, that's the only time that you can see that key. All right, so what you have to do is, once you see that key, copy it and put it at some place safe, where you can use it. All right, so this key, whatever this key would be, all right, you just have to copy that key. All right, and use it to update OpenAI key in your environment variable. All right, how do we do that? I've put steps for that as well. Okay, I will do a small one. All right, even if someone doesn't know coding, they would still be able to follow with this one. Okay, let me know if my screen is visible and you're able to see a Python notebook, Jupyter notebook, that is.
Yes.
Okay, all right. So okay, we have very less time left, but I'm assuming we might be able to go 1 or 2 minute extra. All right, what I've done is I have put a lot of comments so that everyone can understand what we are doing. All right, and I'm going to share this Python notebook with everyone up to the end. Everything is in a manner that you can understand just by reading the comments. Okay, so step 1 would be install the OpenAI package. For that, I have commented this part, right? You can just uncomment it and run it. Since I already have it, I have commented it. Okay, you just have to uncomment it and run it. So this is going to install the OpenAI package for you. All right. Second is import the library and setup client. So because you have recently installed that library in your environment, you'll have it and you can just call it, right? So this is the call for that library. So from OpenAI, import OpenAI and import OS. OS would be used to interact with your own operating system. All right. Now, after that, load your API key from environment variable. Now, a lot of you would find it little hard. How do you update your API key in the environment? And see, this I've put it in bold. Set your keys in your system, not inside the code. Why? Because if you don't know about it, because your system using an open system and open API, if you just put it in your code, anyone on Google would be able to search it, and this all is searchable if you're using a free version. All right. So what would happen is the worst that could happen is whatever $2 or $3 you have put in that one, if someone uses it, the max they can do it, they can utilize that $2-3. Other than that, nothing bad can happen, right? But still, from systems perspective, it's better to put it in your environment variable, right? So I've provided these steps. You just have to follow these steps and you would be able to put it in your environment, your system environment. Okay, now if you have it in system environment, just call it, right? So this is the open API call from your environment, right? So that's what I told you. OS is used to interact with your operating system. This simple line would be able to fetch your open API key for you. All right. Okay, so let's see. Okay, let's just run it. Okay, so as you can see, star is not there, so it is run. Okay, now make a very simple AI request with our API key. So you can directly write response client.chat.completions.create. All right, so this all is coming from the chat library. I mean, within library there are different functions. From one function you are using chat, and then completions.create, right? So this function is under this function, under this function. All right, again, you don't have to learn everything in one go. Just understand what we are doing here, right? And I've also just put some comments so that everyone can understand. All right, now while calling, you have to provide which model you are using, right? So the key that we have used, right, would be charged, right, for the number of tokens that you have used based on the model that you'll use. So we are using ChatGPT 4.1 mini because we just want to do a test. All right, now in messages you give the role, right? This role is, what is the role of this assistant, all right, that we are building? So it is system, content, and you are a helpful assistant. So role would be of system and content is you are a helpful assistant. So this is how it would behave. All right, then role user, content is who score the most runs. So this is your actual prompt, right? You can put your prompt here. You can change the prompt, you will get different response. Whatever prompt you want to fiddle with, you can try with here. So the question is, who scored the most runs in men's cricket in one day internationals? All right, and here we are just printing the response. Let's see. Right, So this is just like the call that you would make with your user interface, but here we have made it through the code. The answer is AI response. The highest individual score in men's one-day international cricket is held by Rohit Sharma of India. He scored 264 runs against Sri Lanka on November 13, 2014. Let's see if it would be able to give another answer. What is the age of Rohit Sharma? If this model would be trained on that data, would be able to give us. Sharma was born on April 20. So as of today, October this, he is 37 years old. Okay, so exactly of my age. All right. Okay, now this was a very good simple call. We realized, okay, how to call with it, right? But there are parameters, right? While you call, there are certain parameters that you can use, right? That could teach you a little more about the model, right? And how you can actually use it in the production, right? So we rest of it is same. Let's look at those parameters only. One is temperature, right? So temperature controls the randomness. So when I say randomness, right, what happens is what an LLM is basically doing when you type a prompt, it is just trying to, as an answer, it is just trying to predict the next word, right? And how does it happen? From the long layer of transformers that we saw, the last layer is the probability of the best answer, right? So if the probability of earth is the third answer, the probability of round or circular is highest, most probably that would be the answer. But you want some randomness, right? So for that randomness, you provide a value of temperature. If you provide the very low value of temperature, there would not be any randomness. It would give the best, most probable answer.
Hey, can you explain what is temperature? I'm sorry if you explained it earlier.
Okay, I think the best way to understand it is again through that transformer architecture. Okay. Okay, is it visible to you? Okay,
Yes.
just one last thing, right? If I've worked, I mean, I've used Zoho for the first time. It says 1 minute left. I don't know. It will continue to let us go after that. If we all close this session by its own. I mean, if it get closed, if you want, I can resend a link. We can restart, or I think 2 hours is enough for all of you because this is Sunday. Anything if you can continue, great. Okay. All right. Okay. So you can see the temperature here. Let me know if you're able to see my scroller.
Yes.
Okay, so let's say we are at temperature 8, right? What we are saying is there is some randomness. So for this, as the spaceship was approaching the station, right, the most probable answer was planet, right? Second was surface, third was station. Now because we have asked it to have some good amount of randomness, right? Hence it can choose from top probabilities. All right, so it could choose, again it would be little random, but it would be choosing between any one of those. Now if I reduce the temperature, right, what it did, it has reduced the randomness. So 100% of the times it is going to give planet as the answer. Does that make sense? A very visual and easy understanding for what temperature does.
So just a question. Is it
Yes.
like if I want an approximation answer, keep the temperature high, and if I want exact accurate answer, keep the temperature low? Is it like that?
Yes, if you want it to perform the same provide you the same output each time, right? But that would reduce the randomness. The problem with that is, for most of the problems that we are talking about where Gen AI would be required, the questions would be very random, right? Because we are talking about textual data, right? So it will not follow the same questions path. Hence the answers path should also have some randomness. Only then the performance of the model would be better, right? So some randomness is needed. All right, but if you have a very specific use case, maybe you're devising it for some medical terminology, where you just want it to give the correct answer, absolute correct answer, right? Then you can reduce the temperature. So what it's doing is, the probability of planet is the highest, so that's why the planet is the top one, right? Surface is next, station is next, etc. Now if you reduce the temperature, right, 100 of it will 100% of the time it will give the answer as planet. As you increase the temperature, as you see, right, their probability would increase for other words to be coming in the answer as well. All right, now next parameter is top P, right? This is again an alternative to temperature. This is called nucleus sampling. So again, it is choosing the from the top percentage, or the likely words which are there, right? So if you use P instead of temperature, if you say P equals to 1, top P equals to 1, right? This is again full creativity range, right? Let's try it here, right? Oh, sorry. So we have top P equals to 0.5. All right. Let's see. I go up. Right. So if we are at 0.9, you can see the probabilities have increased for so many words to come for this answer. Right. Now, if I reduce it, right, you can see the probabilities are reducing for which word would occur. All right. So this is again some way to be keep the model more random and but more creative. All right. Max tokens, this is a very important one, which is very easy to understand, but you all can relate. Max tokens is just giving you a limit, right? The maximum number of tokens the model would generate. Otherwise, if you don't give this limit, right, what would happen? A malicious person would come, would directly say, okay, uh, write a book of 10,000 or 100,000 letters for me, or alphabets for me. What would happen? You would lose a lot of money without giving the answer that the people who would actually need to use that application, right? So max token gives you that limit. Okay, then comes frequency penalty, right? So you don't want to answer, even if I start talking in a manner to everyone, like I use one specific word repeatedly. Maybe it could be like, it could be honor, any word, right? If I, like, I'm using right a lot of time, if the frequency of this word increases more, it might become little off-putting for some people, right? So we want to reduce the frequency of repeated words, so this gives frequency penalty. So this controls the repetition of phrases, right? Then presence penalty. So if what would happen is, if you don't give a value here, right, what AI is doing is, it is not introducing any new idea, right? But if you give it some value, right, so basically uh, you penalize it for being, for not being too creative, basically, right? So give some low value for this as well, so that there is some penalty if you don't become very imaginative, basically, just for the AI, right? For most people, temperature, top P, and max token, right, this is going to be repeatedly used whenever you are making this call. Frequency penalty depends on the use case, right, even for presence penalty, but these three please make sure these would be used whenever you are creating a new call to the API, right? Because this is going to give you a very good control. Okay. Okay. Last topic for today. Okay. After this, we'll close. What are agents, right? Let me hide it so that you won't be able to read it from here. Anyone would like to give an answer? What is your view? What are agents?
Persona that you give to AI.
A persona that you give to an AI. Okay. More answers? Anyone? Amit, Pratibha, Ankit, Aniket. I'm sure that you all would be hearing it day in and day out. Create more agents, AI agent, agentic AI, and all those things. What is an agent?
Can we say it like it's something more specific to some target, or like we have for some specific job to be done? It has been given that, what do you say?
Okay.
Uh,
Yeah. So you're saying it is more something that is moving more specific task. Okay. Yes, Mayank.
Eventually, we don't want to expose the data to entire world. So it should be a closed loop response where we want the agent to read the specific closed loop data and give the appropriate answers to the queries.
Yeah. So I mean, you are right in enterprise world, but again, you're talking about giving that data to an agent. But what is that agent? Getting my point?
No,
Yeah.
yeah,
Yeah.
I understood your query.
Yeah. Yeah. So yeah, I mean, again, the reason to ask this question as well, I mean, from the past question as well, there are some you know uh, things which we hear from different sources, and our brain makes some picture of it, right? But if we talk in specifics, it would make it much clear for future, right? So for all purposes, if you want to give a definition, you can consider it an AI agent is an AI that just doesn't answer, but that can also take actions. All right. Any AI that give you answer, right, is just an LLM call. All right. But if it can perform some action, maybe going and opening a browser, maybe just predefined calculation that you have written, you give it to a variable, and it is able to decide we have to run this variable, right, and take that action. So agent is an AI, right, all LLM call, but which can take an action. Now, one question that was asked to me as well in an interview, and obviously it's a good question. You all would have, or some of you would have known about microprocessors, right? So microprocessing is a known term. We create a lot of processes, and if you define that process, that if this happens at A, do B, or if this happens at A, do C, etc. So you are telling that process as well to be able to take some action, right? Then what is the difference between an AI agent and a microprocessor?
AI will have like it will do some complication, get the context, and then take some actions. Like
Yeah, so
uh,
you don't have to put a deterministic calculation for it. You don't have to say that if this happen, do this, if this happen, do this, right? You just have to give in a high level, right? If things are like this, so again, AI is all probabilistic, right? So that's a good and bad thing. So if you give it a probabilistic cause to or problem, it would perform very good. So you don't have to specify, you cannot specify how many ways a sentence could be written, right? You cannot determine it. So that's why you cannot put it in a code that if the sentence come like this, then do this, right? It could come in different ways, but an AI or an LLM call, it can understand the context from that call, right? If it can understand its context, it would be able to drive, okay, I have to take A path or B path, and an agent is that would be able to take that path. All right, so let's go ahead with it. Okay,
Can agentic AI call and take action on another AI?
absolutely. In fact, most of the so we know about, I mean, again, don't want to bore you with new words. LangChain is all about chains of prompts, but it doesn't mean that you only have to give one role, right? Or use just one AI. You can use multiple AI. You can use multiple AIs to validate the answer that has been created by one AI before giving it as an output, just to have an extra guardrail. Okay. All right. So what are agent? An agent, again, is an AI that doesn't just answer, it takes action. It can think, decide what to do, use tools, call functions, solve tasks step by step, like a mini digital employees. All right. So now directly actually see. All right. So again, we have not created very complex agents, but some agent that could give you an idea. Okay, what is it? All right. So again, this all is same. We are just doing an API call. Now, this is a function that we have created. Simple function, add numbers, right? So this is an add numbers function. If you give it an input of two numbers, it would be able to return its output. All right. All right. Second function is get weather. All right. So we have provided it dummy weather data from this function. So Delhi's is sunny, Mumbai's is rainy, Bangalore is cloudy. All right. Now these two functions, right, we can consider them as tools. So this is a list that we are creating, right? So this part, for some of you who have not worked with Python, you might find it little challenging, but I'll give you on high level what we are doing. This is a way for us to be able to call a tool, right? So this is the function. Now we are putting that function into tools, right? So this is a list. So a list is nothing just like an array. If you would have read about it in school or wherever, right? So like in any C++, etc., you had arrays in Java as well, right? So this is a array. It will have two because this list will have two inputs or two agents. Sorry, it will have two inputs. One is this add numbers function, second is get weather function, right? So you've created two tools. One is going to add numbers, right? And here you are giving it details, right? Type is function. Now name of the function, the AI will call. The name of the function is add numbers. All right. Description helps the LLM know when to use it. So description is add two numbers together. All right. This is what it is doing, right? So you add some description. Parameters, the function expects. So what it should expect, right? Function expect type. So type it because it has to accept all the textual data, so that becomes object. But if you talk specific in numerical terms, right, it will always be numerical data, which is integer or float. Okay. Properties, a is going to be a number, b is going to be a number, right? These parameters must be present when calling. Required. If you don't have two values, it will not be able to sum them, right? So if there would need to be a sum, there need to be two values. Okay, so this is one. For second one is type function. The function name is get weather. This is again just a prompt, right? This data would be used by your agent, whatever agent will create, right? Description, get weather for a city from the demo data. All right, this is all plain English, right? We have already created that function. This is just how our agent would understand during that LLM call. All right. And then properties, city. So type is string. So all this data, if you can see, this is all string data, right? Textual data, all right, which is a required field. If you have to answer for this question, you at least should know which city you're talking about, right? So if this is not there, agent will not be able to decide what to answer, and it might ask us a question if you have handled your error like that. Okay, so now this is done. After that, step 2 is user input. So this is going to be your user input. Now user input, what is the weather in Mumbai, right? Now again, same response, we are calling messages, role, user, content, the same way we used it, right? Now we are using one more thing, one more parameter. That parameter is tools, and we have defined our tools here. All right, so these are again two uh, prompts, English prompts that it is going to use. All right, now we get an output as response choice. All right, here this is what we always have to do, right? This much of code would be required for it is to actually understand from the argument if what happens in that scenario you have to call add numbers, and what happens in which scenario you have to call get weather. All right, so because these functions have been used on the top. All right, I've already put everything in comment, so hope whoever has worked on any of the coding language, it would be very easy for you to understand. Whoever is not, you have to give it a few go, and in few instances I'm pretty sure you would be able to understand this. Okay, so now let's actually try. Now the question that we asked in the user input, where was the input, what is the weather in Mumbai, right? So the agent was able to decide that what kind of question is it about the weather, or is it about the calculation, right? So now instead of that, let's ask a different question. Can you add 2 and 3 and give the total? So now it has been able to understand that you have to add two numbers and give values. So it has now called this function. All right, so the difference is, if it would have been a process which is deterministic, you have to actually define what happens, then what you should do. Here you can add in multiple variants of this prompt. It would, from that context, it would be able to understand which function to call and take that action. So that is what an agent is. It would be able to decide and then take action. So that's your agenting. This is on a high level. This could be very complicated as well. All right, so with that, our today's session is over. All right, any questions on any of the topics that we discussed today?
This is wonderful. Thank you, Sarah, for this session. Although I joined a bit late, but
Okay.
whatever I attended, it is really great.